Okay, so the purpose of this video is to help you get started on your Piecewise Art project, and also hopefully to answer some questions that you might have about the project and about getting it done. So let's start by going to opening up a Desmos window. All right, so if we go to desmos.com and click the big red button, then we get a blank Desmos file, which is not where we want to start, but we're not starting our project yet. What you want to do is make sure that you sign in using this sign in button here. Sign in with whatever account you want to use. And then once you've signed in, if you go to the top left corner to this little 3-bar menu, then you can access any of your previous saved graphs. So a couple of examples of projects that have been done in the past. Here's a penguin from Madagascar. Again, these are projects that were slightly different than the ones that we're doing now, but similar enough. Here's a stormtrooper helmet. Let's see what else we've got. Pittsburgh Penguins logo. If you want to see any more examples, then feel free to ask me. I'll be glad to show you some more that have been turned into me in the past. Or again, if you go back to the main Desmos page and you scroll down, they've got some examples here. Again, for inspiration, not for copying. You will get a 0 and a referral if I find out that you have copied any. So when you start creating, you actually don't want to go here. What you want to do is you want to go to the file that I shared in Google Classroom. So in the Piecewise Art Project post, the first link is to the information about the project. The second one is the Desmos file. So once we open this, then we get a whole bunch of stuff in this left equations column that's already put in. And what I would do is go ahead and type in your name. Oops, that's the title. We don't know what we're going to do yet, so we'll leave that to be filled in. Type in your name. And then go ahead and save it. If you haven't logged in yet, go ahead and log in. And then go ahead and save it. Again, Desmos doesn't auto-save, so you'll need to be mashing this green button as often as you can remember to. So if we want to get started, then we want to choose an image. Again, like I said in class, I encourage you to pick something that you're interested in so that you'll be motivated to turn in a quality project. So when you find that image, let's say you've downloaded it to your desktop or whatever, then click on this plus button, the image, and then choose the image that you want to import. For me, I'm going to make this a little bit bigger. I'm going to keep it centered about the origin, but I think, let's see, in order to not use just so many, we're going to have decimals either way, but let's see. Just grab those corners and make it a little bit bigger. All right, so that's about how I want it. I'm gonna, for my image, since mine has text in it, I really just want to model this logo here, and not necessarily the text, and that's fine. If your image has a lot of details, if it's like a photograph, you don't have to model all the textures or everything that's in the image. But the main part of it, I want the main part of it to be created with equations or modeled with equations. So I'm going to take this image. Let's see, I'm not sure why I put it down here, and drag it into the first folder, which is the image folder. And you know that you've got something in a folder when you've got this little vertical line next to it, and you can kind of turn this triangle and open and close that folder. And you can also click on this icon on the left and turn off any graphs or images that are inside of that folder. I'm going to go up and save it. And then, so the next thing I'm going to do is I'm going to start modeling my image here. I'm I've got this linear example in here just kind of to show you the form. I don't need that for mine, so I'm going to go ahead and delete that. And then the other thing I'm going to do is I'm going to go ahead and just make up some space for myself. I put a lot of folders and other stuff in this file that kind of makes it look a little crowded. I like to have a little space to move around and to add in equations. All right, so first equation, let's see. Maybe I'm just going to do a couple of pieces. Maybe, I don't know, maybe I'll start with this line here. So this bottom line of this red stripe on this bantha, I'm going to try to model that. So thinking about my linear equations, I think of slope-intercept form, so something like y equals mx plus b. And I need to know my slope and my y-intercept. So my y-intercept looks something like 3, maybe a little bit more, 3.1. And for my slope, let's see, if I just put in a 1 there, whoops, then that's too much, too steep. So I want to go down, let's see, 0.75. Definitely not enough. Let's go with 0.5. And this is the kind of thing where you can either play around with, or you can say, well, I'm going to pick a couple points. If this were to keep going, then it looks like it would go approximately to 6.4. So that's like going up 1 over 4. So what if we tried 1/4? That's closer. Not quite. Let's try 0.2. Still not enough. 1.5. Ooh, that looks pretty close. All right, so I feel pretty good about that. I might even move it down just a smidge. Is 3 enough? How about 3.05? All right, so that looks pretty good to me. So then what I want to do, I don't want to leave it like that so that it's going off of both ends. If you zoom out, then you see those tails. So I want to cut it off. So like right about here, and you can even click and see right about what x value you want to cut it off at, maybe somewhere at negative 7.6. So then after your rule, your equation, if you do your braces, and then your left bound, and then less than x, less than, and then your right bound. So if I go back, let's see. Well, let's just see what that point is. Looks like 5.75. Let's see what that looks like. Okay, so again, if I turn on and off my image, that looks pretty good for that part right there. Okay, so that's the lower part of here. And again, the colors don't really matter, just modeling the image itself. So then let's see, if I wanted to do this part right here that's curved, I could think of some of my curved functions, and we've got quite a few of those. We've got parabolas, we've got trig functions, we've got exponentials, logs, who knows. What if we try to use I don't know, an exponential. Let's go with an exponential. So for my exponential, so I know that my parent function is y equals, we could use whatever base we wanted to. Because I want it to be, well, let's just use e to the x. And we're gonna want to transform this quite a bit. Okay, that's obviously not gonna meet this curve that I want it to. I'm gonna want to reflect it and translate it. So what you can do is you can throw in your modifiers if you'd like, kind of in the same transformation form that we've studied, like so. And then Desmos will ask you if you want to add a slider, and you can add all, and then you can change each one and then see which values you want to keep. What I don't want you to do is leave these extra variables in your final product. I want you to replace those with the numbers that you want. So I know that I want my a value to stay positive, but I want my b value to be negative because I want that to be decreasing. And then I know I want to shift it up right around here. So my h value is my horizontal stretch, k value is my vertical, or excuse me, shift, not stretch. All right, so we're looking at something like that. Let's see. All right, so I can change the stretches in each direction. want a little bit more vertical stretch, more horizontal. And again, that's not perfect, but that's pretty good for now. So I would want to go through and put each of these actual values into my equation, because I'm going to get rid of these sliders in just a minute. And again, make sure that your equations are in this vertex form, especially your toolkit and trig functions especially. If they're not in this form, if you have more than one horizontal stretch or horizontal reflection or more than one of one type. So like, for example, if I had a number in here, that's not okay. Make sure it's in that form from Unit 1 and that you learned back in Math 1, Math 2, and Math 3. So then I can get rid of these. All right, and then I want to cut it off at these points. So this looks like something like 4.9. And then this one intersects the line that I had at 5.71, so I might stop that one there. So 4.9. All right, so cutting off my domain. What do we say? 4.9 less than x, less than, and then we said 5.71. All right, notice how if I get rid of my image, notice how it comes over and it intersects just right there. I might even, when I go back in and change this guy right here so that it doesn't have that little tip, that little overlap there. If I change this one to that same value, 5.71, then it'll be a nice and neat corner right there. All right, so that's two of those values there, and that's two examples of our kind of traditional toolkit function. So then what I would want to do when I was done with these is I would want to take and drag each one into the appropriate folder. So this is a linear equation, so I want to drag it into my linear folder. This was exponential, so I'm going to take this, drag it into exponential folder. And again, you can do those at the very end. You can do it as you're going along, whatever works for you. So next up, I want to show a couple examples of the other types of functions that you'll need to include in your project. So conics, we just kind of finished that unit, so I'll skip those for now. But polar and parametric are two other types of functions you need to include in your project. Going back to our rubric, on the second or third page, then we see that we need at least 7 of our different toolkit functions, at least 4 of our 6 trig functions, 3 out of 4 of our conic sections, and then scrolling back up to the rubric on page 2, we also need at least 2 polar equations and at least 2 parametric equations. Okay, for the polar equations, one of them must be conic. Again, we studied those in Unit 8. And the parametrics, we studied those in Unit 6 along with other polar equations. You can go back and look in your notes for those. If you need some other help on that in the FAQ that I've also posted in Google Classroom, further along in the questions, if you need to be pointed in the right direction for any of those, I've put some links in there, just PDFs and back to our website, and you can look back at your notes or any of those video notes. You're welcome to. So let's see. If we want to do a polar equation, then we want to start with r equals, and we want it to be something in terms of a theta. Again, you can type in a theta. You can go into your keyboard, and it's somewhere in here, I think in the ABC menu, it's theta right over here. So let's see. So what are we going to model on this bantha with a polar equation? Let's see. So we've got a bunch of curved things up here. What if I try to do some of this curve here? I won't be able to do all of it, but some of it with the polar equation. So that looks pretty circular. Let's see if we can make that happen. Let's see here. what happens if we just do sine of theta? Let's turn that back on. All right, so sine of theta, so that's a circle here that's symmetric about the y-axis. We can make that bigger by changing that value there. Shifts don't work the same way in polar as they do in our traditional rectangular functions, so we can't just put it into a vertex form. What we can do, and we looked at some of these in class, if we do plus a cosine of theta, then we can do some shifting here. Let's see. And again, we're going to need to just kind of play around with this a little bit. And let's see, I'm going to shrink these, and I may not even get to modeling that exact curve that I was initially aiming for. Let's just see what happens when I change these values around a little bit. And let's see, what happens if I put a, oh, that changes things quite a bit. What happens if I do, wow, that's crazy. If I put one on each one, is that gonna, so that makes us what looks like a rose curve almost. We don't want to do that. Let's see. What if I make this a little bit bigger and see if we can't model let's see, one of these edges. It doesn't give us much to work with. What happens if we just throw in another theta? Whoa, that's crazy town. Okay, so it's not perfect, but I'm going to take this piece right here and maybe just model this piece right here. Again, ideally, I would want to take a little bit more time and maybe come up with a circle that could model all of this here. Another option would even be to come up with that equation in rectangular form and convert it to polar form like we did in Unit 6. But for time's sake, let's see if we can model that right there. So that looks like it goes from, let's see, 8.5 over to, I don't know, 8.7. The problem is with polar, they don't think in left, right, and up and down. So when you restrict your polar equations, you've got to restrict your theta. So what you want to be thinking about is approximately what is that angle from the origin up to here. So 45 degrees, or let's see, if we go back up to our wrench, we're in radians. So that's about pi over 4. Let's see, is it going to mess things up if I change that to degrees? Nah, let's go to degrees. Let's see, so going through here, this is 45 degrees here, so I'm looking at maybe, I don't know, let's try 40. Oh, I did not just do that. Undo, oh my gosh, is your friend. You can click these undo and redo buttons up top here. Let's go to maybe 40 is less than theta is less than 42. Okay, and we see this curve up here, so I went too far. I want to go back down here. So let's say maybe 35. Okay, so let's go up a little bit more, 36, that looks good. And let's go back down to 40. Okay, that's too much. 39, 38. Maybe I'll leave it just like that. So again, that's not much. Ideally, if I were doing this for my project that I would want to turn in, I would want to get a better circle that would have been shifted and would give us a better model of this. But I just want to show you what you need to restrict for polar and what form it's in. All right, so if I feel like I'm done with that one, then I would drag it down into my polar folder, which is towards the bottom. All right, and then let's see. If we want to do a parametric, let's do one more example of parametric. And remember, parametrics in Desmos, you graph those as if you're graphing a coordinate pair. But for the x coordinate, you're going to put in your equation, your x equals equation. So let's say, I don't know, let's do 3t. And your y coordinate is going to be your y equation for parametrics. Let's say that's just t. All right, and then notice how they, your restrictions for parametric is going to be restricting your t values. So for starters, I want to make this kind of big because I'm not sure what my graph is going to look like. So zooming out a little bit, because I plugged in two linear functions, and I'm going to get a linear as my output. Let's say I want to try to model this top line here. So what I want to do is I want to shift this up some. So my y coordinate, I want to go up a bit. So let's see if we go up 2, 3, 4, 5. Let's see, 4.5. All right, so that looks pretty good. And then I want to change the slope, which is going to be the coefficients of our two t values. All right, so let's see, what did we decide on was the slope of this line here? We decided that was 0.15, so that's close to a tenth. What if I make this 10? Ooh, that's pretty close. 11, 12, I'd say that's pretty close. Okay, zoom in, get some more detail. I might want to shift that up just a hair more. That's too much. All right, that looks pretty good to me. All right, so now what I want to do is I want to cut it off at these 2 points. For parametrics, again, you're plugging in these t values. So you might need to play around with those numbers or make a table and see what points these are plotting. For my x coordinate, I want to get somewhere between -6 and -7. So if I want 12t to be, let's see, -6, I need that to be -1/2. So if I make this negative, let's see, -0.5. All right, so we see it cut off right here. That's a little too much. So I'm going to go, let's see, -0.75. That's too much there. -0.6. 0.5 is too much. So somewhere in between there. 0.52, 0.53. That looks pretty good. All right, and then coming over here, this x coordinate looks right about 7. Okay, so to get 7 from here, I would need to set this equal to 7, so that's going to be somewhere around, I don't know, let's try 2, let's see, 1, see that's our y coordinate, that's why that's not making sense. So if I go back to my x coordinate, then again I want this to be somewhere, let's see, past 6, so past +0.5. But not quite there. So if we go -0.45, -0.4, that's a little too much. 0.42, 0.41, and that looks pretty good to me. All right, so my restriction for my parametric is from -0.53 to +0.41 for my t parameter. All right, so if I felt comfortable with that, I would take that equation and drag it into my parametric folder, which is going to be towards the bottom again. All right, I'm going to save it. Make sure I save that before I close the window. And again, we got a couple of lines drawn. I hope this helps. If you have more questions, back in the Google Classroom post, the third link is the FAQ. I'll be updating this as I get more questions from you guys. But make sure you go here first. Make sure that you read through the rubric. I've got point values for each thing I'm going to grade when it's turned in. Feel free to send me an email. If you have questions, feel free to come and see me before school, after school, or during lunch. and have fun with this.